Got it. Okay. So today we will be taking the subject called design patterns. Okay, so design patterns, why we use design patterns, and how we gonna be leveraging design patterns in our application. What sort of thing that design pattern can do for us, and why in the first place the design patterns was included in programming. Okay, so there's this nice website called Refactoring Guru. It's give us a lot of information about design patterns. I really like this, so I'll be using the I'll be using this website to explain the things going forward. Okay, so so what is a design pattern? Okay, why do we, before we use it in our codes, or we use it in our applications, we need to know what is a design pattern. Okay, so let me zoom in a little bit so you guys can see better. Okay, so design patterns are typically solution for a common occurring problem of their design. Yeah. Hello. Okay, I think Mike. So design patterns, they are just solutions for common problems occurring in software design. So we have things like application problems, like right now what we are trying to resolve within design patterns is like there are common problems that any application would come. So we are developing a simple REST API, we are developing a desktop application, whatever the applications that we're going to do, there are going to be problems, commonly occurring problems that we need to solve somehow. Okay, so design patterns is a place where we can get an inspiration for commonly occurring problems. Okay, so always remember, design patterns gives us a solution to commonly occurring problems. Okay, so do not mistake do not mistake these things like algorithms. So there is a common thing like design pattern is an algorithm. No, that is not. Algorithms will discreetly tell you what are the steps that you need to get something resolved. Okay, but in a design pattern, you do not get the problem is, okay, we have a different approach to solve the problem. Okay, so that do not get confused algorithms with design patterns. Those are two different things. Okay, so think design patterns are like blueprints for commonly occurring problems. So they are not something, it is not something like written code or something like that. It's a solution that can be implemented in any language. Okay, so you have you have the design pattern definition. Based on that definition, you can implement it in any language or any framework of your choice. So using those kind of thing, you guys can see the design pattern as a blueprint. Then using that blueprint, you can commonly resolve these problems. And the and also when you're talking about things like design patterns, you can't just sometimes copy paste these things and it will work. It is not something like that. Okay, those the design patterns that we discuss is going to be something like a thing where we can apply and reuse in any other place as well. So for example, I have identified a common problem in our application. So we need to make some resources available throughout the application. And the application, the resource that we are going to access is going to be heavy, uh, heavy application, heavy resource base piece of resource. So the resource is there, and it is taking the instance is there. It is taking good amount of resources. Okay, so if we if we have one, if we have that instance clone everywhere, then it gonna since it is consuming more resources in the application, it's gonna crash our server. Okay, so we do not want to happen some things like that. So in order to avoid such duplications, in order to avoid such resource intensive task, what we can do? Okay, so the problem is uh, we have instance that we need to create, but it is taking a lot of resources. To minimize or to mitigate the resource intensiveness, what we can do? Okay, so that's kind of problem is there. What we can do right now is we can there are common solutions for those kind of things. Okay, so it is not clearly mentioning, okay, this implementation, if you want to do this implementation, you should follow these patterns. No, it's not going to be like that. Of course, there will be most common implementation in known programming languages. Say for example, we have a design pattern, okay, and we can search in the web and get, okay, these are the example for the design pattern written in Java. This is the design pattern implementation on TypeScript. You will find the implementation, but again, it is not language specific. So it is the design pattern that we are using. It's not going to be only for Java, only for TypeScript, only for Swift. No, that is not the case. But remember, design patterns sometimes openly have limitations based on the capabilities of the language. Okay, sometimes some languages do not have capability of implementing such things. So it might be limited on some programming language, but most of the time, 99% of the time, it's not going to be an issue. All the programming language have the similar concept. So implementation would be something similar. And remember, one other thing is that the design patterns are not something like libraries. So if you guys can remember, we used Express.js within our Node application to develop REST APIs. Okay, that is the library that we have used. But don't expect the Express design pattern to be something like Express.js. We just import it, or we just install it and use it. No, there is no such a thing as a design pattern package or something like that. There might be some solutions which are using design patterns under the hood, okay, but they are not like out of the box design patterns that you can use like a library, or you can import it and work. Okay, and remember, it is a concept that can solve a problem. That's it. Okay, it's just giving us, okay, if you have the problem, okay, this is the way, or this is the solution that you guys can do. By implementing, you will have a solution for this problem. That's it. It's not going to show you how you're going to do it, what is the programming language, no, nothing. Okay, so implementation of these design patterns, you can often find, as I mentioned earlier, but it is not always going to be like a ready-made available for you guys. Okay, so yeah, that's what we talked. So have this in your mind, like to understand the difference between an algorithm and an algorithm and algorithms and design patterns. So the analogy to algorithm is like a cooking recipe. Both have clear steps and achieving goal. One on the other hand, a design pattern is more like a blueprint. You can see what is the result and the features are, but the exact order of implementation is up to you. Okay, so algorithms, you will have these instruction. Okay, first do this, second you do this, third you do this, and go on. You will have this result. But in a design pattern, you don't get the exact steps, but you get the idea. Okay, this is the blueprint. Okay, so this is gonna be the blueprint of your problem space. You can get the solution out of this, but how you gonna implement it, where what is the mechanism that you're gonna do it, it's up to you. The design pattern does not enforce you on that. Okay, so um, um, so in a nutshell, if you want to if you want to express a design pattern, okay, express how we gonna show a design pattern to someone else. So there are key four things that we need to discuss. Okay, so by talking around these four key points, we can get an idea why this design pattern is there, and what are the things it will do, and what is the structure of this one. Okay, so there is intent, motivation, structure, and code example behind a certain pattern. So we will look into um, uh, several design patterns and try to explore these options. Okay, all right. So the history, I'm not gonna go into lot of history around this, but there were like very smart people who come together and they solve. Okay, there's a problem like we commonly face the same kind of problem every day. So what we're gonna do is we're gonna come up with a pattern, so we do not want to reinvent the wheel, and we can share these patterns to people who are having the similar problem, so they can also leverage that. So it came around the concepts like object-oriented designs and object-oriented programming. Okay, you will guys get to know around these things. So there is the smart people behind that, the gang of four, and there are a lot of books written behind it. But I highly recommend, if you guys have time, to read the design pattern, the original guideline. But if you're not, just let's go with the basics and try to understand what's going on in here. Okay. All right. The next thing that we're gonna do. So you might ask, okay, if the solutions are there, if everybody knows, if everybody have the idea, then they know about the design pattern. Why do I care about the design patterns? Okay, and what's gonna be beneficial for me in this scenario? The first thing is, um, there when you go to industry, when you work with some projects, sometimes even within your projects, sometimes you have implemented a design pattern unknowingly. Okay, you have used design patterns without your knowledge, without thinking about it very much. Okay, uh, so in a case like that, what will happen is you can't have a label around it. But what you have done is, it is okay, then you might use the same technique for something else. Okay, but the thing is, why do we if it is works, if it is working for me, why do I need to learn separate someone else separate code within me? Okay, my programs work as expected, so I have my own way of doing that. I have solved the problem, so why do I need to you need to know how others solve it. The first thing is, as we discuss, design patterns are like blueprint. Okay, so these things have been tried out by people who have been developing software for long, and they have tried it and they have tested it. Okay, they are working perfectly. So you might also use something like something of your own implementation. You can come up with a solution for your problems with your own terms. Okay, but the thing is, the problem is when you have such a thing, when you come across your own solution, how do you know it is not buggy? Okay, if it is, if that solution that we are trying to, the problem solving mechanism is bug free. Okay, so have we tested it thoroughly? Okay, I have found a way to get things up and running very quickly. But how do I know that the way that I have discovered, the way I have coded this is the optimal solution, whether it is the right thing, or whether it's going to be future proof, whether it's going to be working on different environments. So the design patterns gives you that confident. Okay, design patterns are tested out throughout so many software companies, software engineers, so many brilliant people out there. So we know that these design patterns works. Okay, these design pattern works. They have tested thoroughly, and they are used in different programming languages, different projects. So we know for sure that is working. So rather than having my own homegrown solution, if the design pattern is doing a better job, I would recommend, okay, if it is matching our requirement, we should use a design pattern rather than implementing our own. Okay, and the other thing is communication wise. Okay, so say for instance you have a homegrown solution for your problems, and now you want to convey that to other people. Okay, that I'm going to be I'm having a blueprint to such a solution, and I need to express it to someone else. I need to give how we can do this. Okay, there's the problem is this, and I have come to my conclusions or with my findings by doing this, by following these things, or by doing this structure, we can get the solution. So now what we have to do is we need to have a common ground with the colleagues that we are working, right? We need to express that problem to someone else. So how are we going to do that? The best way that we can do is have them named, right? We can say, okay, rather than, okay, use this chunk of blueprint, you can always say, okay, let's use that design pattern. You can specifically say the name of the design pattern. Then everybody in the rooms, if they are familiar with the design pattern, okay, if they know, okay, this is the design pattern that will suit, or this is the functionality this design pattern do, they can easily adapt it. Okay, so without compromising the team, you can say, okay, let's use this design pattern in this particular problem. So everybody else, they know, okay, this is what this guy is talking about. They have an idea what we are dealing with. Okay, so rather than having random names or unknown things, everybody can communicate in one single language. So if somebody is not knowing, okay, we will say, okay, I will use this design pattern. Then anyone else who does not know the design pattern, they can easily go and search up the term. Okay, so I would say I will come. Let's say we are in a meeting and we come across some problem. Okay, we have a coding problem right now, and by looking at this problem, you guys are giving it, this is the problem, this is what it is causing, how are we going to fix that? Then I would definitely say, okay, let's use this design pattern. Okay, let's name it as X. let's use X design pattern in here so we can solve that. So everybody knows about the X design pattern. They can say, okay, yeah, that would work. We can try it out. And if somebody does not know about X design pattern, then they can search up in the Google or what in the web, whatever the choice, and they can learn about it. Okay, so everybody in the same page. Okay, everybody knows, okay, when we are talking about X design pattern, they are talking about these and these things. So they can easily learn without giving a lecture on X design pattern. Once they know how X works, they can easily implement them, they can communicate easily. So that's kind of mentality is there with the uh, adaptation of design patterns. Okay, so sometimes it is not always the use case, right? You will probably think, okay, then design patterns are the best. Okay, it's gonna be the thing that we're gonna do for everything right now. Before we do a code, if we come across a solution, now first thing that we're gonna do is find a design pattern that match the problem. No, that is not gonna be the case. Sometimes uh, it is not suitable on certain location, certain situations. It's not gonna be like a silver bullet. Design pattern will resolve everything that we have. Okay, it's not gonna do that. So as I mentioned earlier, there are patterns which is will not make use or will not make any sense in certain programming languages. Okay, so certain programming languages you would say, why do we need to go this hustle? We can simply do in this certain ways. The programming languages, programming features that they provide will have an alternative to the suggested solution in a design pattern. So in a scenario like that, we do not want to overcomplicated things. Okay, so there are like uh, there are like programming languages which really do not need such patterns. So especially if you consider as I mentioned earlier, the design patterns paradigms came with things like object-oriented programming. Okay, so we have object-oriented programming that handles most of these uh, problems. But some programming languages are not object-oriented, 100% object-oriented, or they have loose way of doing it. In a scenario like that, you might think, okay, this is ridiculous to have this kind of patterns in here. So make sure it is not like silver bullet to everything. If you can do it easily, if you have a solution that is provided by a framework, by language, then probably go ahead with that rather than overcomplicating stuff. Okay, so and the other thing is over usage. Sometimes what we do is when we know all these design patterns out there, then what will happen is to each and everything that we are trying to do is we're going to apply the design patterns. Okay, so a simple task, okay, let's add this design pattern over here, and for a very small amount of project, you would say, okay, no, we need to have this design pattern in here. So sometimes it does not make sense to work in such way. Okay, so do not get overcomplicated with these things. Do not use, even though you know the things are there, Okay, so do not use these things in every time, and you will get a lot of issues when you're using design patterns everywhere. Okay. Okay. Next thing that we're going to be use is classification of the design patterns. So we need to learn about uh, design patterns can be classified into main category of three. Okay. So based on the objective of the design patterns, we have three different ways, three different categories, if I say. So there is creational, structural, and behavior patterns. Okay. So creational patterns is a mechanism, as it's implies, how we gonna create objects, and how we gonna make use of creating new objects in our programming languages, or in our projects. Okay. So there is like structural, and the structural patterns is like how we gonna assemble objects. That means we have created object. Okay, we have created something. Now how we gonna incorporate other objects into this, how we gonna do that. So that is kind of like the structural patterns. And there is behavior patterns, and behavior patterns is like how we can interact with these created objects, or created um, um, created instance. Okay. So we have creational patterns where it says how we gonna create these things, and we're gonna have structural patterns, how we can add more things to that, and then building, or we can say building or assembling the objects, and the behavior patterns that says how we can interact with these created instance. So these are the three common categories whenever whatever the design patterns that we're gonna come across, unless it's gonna be like something revolutionary for upcoming years. These are like the three key pattern categories that you will find any of these design patterns comes into. Okay, so we'll look by the category and try to understand these design pattern by their use case. Okay. Okay, so as we mentioned, there is creational patterns, there are structural patterns, and there is behavior patterns. So these patterns are the the usage, or using the smallest things, or the most grouped mechanism that you will find in design patterns. So we'll look into creational, then we will go to structurals, and there will be behavior. So right now, you guys can see there are a lot under each wing, or within the group. So within the creational patterns, you have the factory method, abstract factory, builder, prototype, and singleton. And when it is coming to structural patterns, there is adapter pattern, the bridge pattern, composite, decorator, facade, private, proxy. And when it is coming to behavior patterns, you will find something: chain of responsibility, command, iterator, mediator, memento, observer, state, strategy, and template, and visitor. Uh, so these are like the all the design pattern categories you will find. We won't have time to go each and every design pattern within this course, or within this lecture series, because some of them are really advanced, but we will at least try to cover uh, several design patterns from each, so we can get an idea on how these things are going to be working, how these design patterns will make things easy for us. Okay, so probably you guys have used design patterns without your knowledge. Okay, probably you have heard the thing, okay, this is this design pattern. But right now what we will do is we will try to understand with the 4 iteration questions, and we'll try to get things up and running. So these are like the as I mentioned earlier, the groupings. So as of now, do you guys have any questions with the groupings? What design pattern is trying to achieve? What sort of mentality behind it? You guys have any questions? Just ask. Okay, so hopefully after this, after we talk about each and everything, then you will get more questions upon this. First, we would be using the things like the singleton pattern. How the singleton pattern is the most commonly starting point for creational patterns. So we will start with singleton pattern. So probably when we create the REST API application using NT architecture, we unknowingly actually use singleton pattern. Okay, we have used singleton pattern, but probably you guys did not notice at that time, and did not care about it the first time. But when you understand the concept, when you understand the blueprint of the singleton pattern, how singleton pattern is working, you would get an idea. Okay, this is what we have done in our REST API application, and this is the point we have created the singleton in our application. Okay, likewise you will get a glimpse of the use cases of each and every design patterns that you will find out there. So let's go to singleton, and you guys can see singleton is a creational pattern, and that you ensure that a class has only one instance while providing global access point to this instance. That means um, when we talk about object creational patterns, so we are supposed to create some instance, right? In creating, when we are talking about object oriented world, we want to what we are trying to do is we want to create an object, we want to create an instance of a class. By using a singleton pattern, what we do is we create instance, but the but when we create a singleton instance, the um, the mental or the use case behind the singleton pattern is as gonna be only one instance for the whole application. Okay, there won't be many of instance that would be created by within our program. We will have one single instance that will be represent to any part of the program, and the same instance will be used across different part of the program as well. So if you guys can remember, such a case would be the database connection that we have done. Okay, we have done a database connection when we are using the tiered architecture. Okay, so we use in our example, we use the type ORM database connectivity, right? We use type ORM database connectivity. So in our app module, we use the configuration, we provided the things like what is the database name, username, password, ports, and everything. We just gave those information. And if you guys can remember, we did not create any database connection after that. We have provided the database connectivity through the whole application. And what we have done within submodules, within the, not only within the app module, we had the user module, login module. We had several other sub modules, but within those submodules, we did not instantiate the database connectivity. Why? As I mentioned earlier, database connectivity is what we call is resource intensive process. So creating a database connection takes a lot of resources from the database as well as within the application. So if we create database connectivity per module or per request or whatever the reasons that we are going to do, what will happen is it will overwhelm the system. System can't have like 1,000 database connectivity. Rather than, what we'll do is we will create one single database connectivity using Singleton pattern and use that connectivity to execute queries against that. So we have one single connectivity, but we execute different queries. Okay, we execute create queries, we execute select queries, update queries, whatever the queries that we're going to be executing will be executed under one single database connectivity. So we have one single database connectivity and we reuse that throughout the application. Same goes in here. So when we're using a singleton pattern, what we will do is we will create one single instance of it and we will reuse within the whole application. Okay, that is the mental behind it. The problem is the single pattern solves two problems at the same time, violating the single responsibility principle. We will see what do you understand by single responsibility principle. Right now, what we're going to do is we will have one single instance, only one. Okay, ensure that the class has just one single instance. Why would anyone want to control how many instances a class has? The most common reason of this control access is shared resource, for example, database or file. Yeah, as I mentioned earlier, you might ask, okay, why do we need a single instance? Why do we need a single reference? The main reason is resources. Okay, you can't go around in your machine and creating thousands of instances which will be utilizing your memory. That would be hard. So the mental behind that, so we have created one instance, okay, one object, and after a little bit while you have decided to create another one. Okay, so what you will do is rather than creating a new object, okay, you will get what we have already created. Okay, the same goes to the database connection example that we have used. So take this example once again. So we have the user module and we have the login module. Both of these modules will be interacting with the database. Okay, both of these modules will have some sort of queries to be executed. They need a database connectivity. So when we look at when we interact with the user module, we will need a database connection. And again, when we are interacting with the login module, it will also need a database connectivity. So rather than creating two different instances, what we can do is we create one single instance of the database. And the first time we create it, let's say, for example, we are accessing the login module first. When the login module is accessing, we'll check whether is there any existing instance. If there is, we will provide that. If there is not, there is no single instance created for now, what we'll do is we will create an instance and return it back. Okay. Ultimately, the problem that we are trying to solve is having only one instance to have within this application. Okay, so rather than creating too many database connections, we will have one and we will reuse it. uh, uh, so you guys know constructors, right? When we are creating constructors, um, we use in different languages, we use the keyword like new, and we pass the parameters, and we can create the object of choice. Okay, but in a regular constructor, you can't have you can't create what we call a singleton. Each and every time when you call a new instance, what will happen? It will create an instance. Okay, so let me show you guys an example. I'll take the Angular application that we have been creating so far. Start a new shell. I will add this code to this list. Okay, so hope you guys can see VS Code. Let me create a temporary file. Yes, use example dot. I'll call user utils.ps. Okay, zoom in a little bit. Okay, so we can define a class. Simple enough. We can say class user. We'll just call it user. Okay, so whenever I want to define whenever I want to create an instance of this class, what I can do is I can say I'll have a function to create this, otherwise it will not work. Create user. And what will happen is, if I want a user, I can say user new user. Okay, simple enough, fair enough. So we have a class called user, and by using the new keyword default constructor, we have created a new user. A new user instance is created. And then again, I want to create another user instance. I can say user2, and I can say new user. Then again, what will happen? Since we are using the new keyword, the default constructor, I can create another instance. Okay, so the first instance is instance user. The second one is called user2. So I have two different instances of the same class user. So this is what we call not a singleton, because user1 and user2 are two different objects, even though they have come from the same class. The class is same. The blueprint for the creating user class is going to be same. But since we have used the constructor, new keyword, user one or the user class will have a different instance, different location in memory, and so on and so forth. And also, since we created a new instance of the user and we named it at user2, it will have a different, it will be a different instance. It will allocate memory in a machine in a different memory location. This goes on. Okay, so these two are not identical, even though they are using the same blueprint. They are not identical. You can't have these things as one. Okay, so this is not in an implementation of singleton pattern. So how are we going to make this class a singleton? The main thing that we need to remember that using the default constructor, this constructor that we have used, it's not gonna work as it is. So we have constructor in here. Okay, this is the default constructor. So we can say default constructor. Default constructor. Okay, so this is the default constructor. Even though we have not specified it, this is what happening in the background. So the default constructor will create two instances. By using this default constructor, we can't achieve the singleton. Okay, we have to make sure this constructor is disabled. Why? If we allow this default constructor, anyone can create an instance of it. Okay, if anybody wants to create this, what will happen is they can use the default constructor and they can create a singleton instance. So that will violate our singleton design pattern. So first thing that we need to do is we need to make sure this constructor is not open. Okay, this constructor is not publicly accessible. Okay, so if somebody can call this constructor and they can create something, then what we need to do is we need to stop exposing this constructor to outside world. We need to make sure this constructor is disabled. So how are we going to do that? How are we going to make a constructor disappear? Anyone have any idea? So if you guys have learned object-oriented design, object-oriented basics, there are certain things that we can restrict within the class. Okay, there are certain things we can say, okay, the class and its subclasses can access, and there are things like anyone who has access to the class can access. Okay, so we have something called access modifiers. Okay, anyone have used access modifiers? Raise your hand. Okay, I know what access modifiers are. Yeah, you might have used it, you might know, but in a case, so access modifiers like public, by default, this constructor is a public constructor. That means anyone outside of this class can access this constructor and create an object. Okay, that's why the public keyword is not normally shown. So if you want to strict this access, if you want to make sure this public constructor is no longer accessible to anyone else, what we need to do? There is another access modifier, what we call a private. Okay, so once we make our constructor private, you guys can see that we are no longer able to create user instance as we wish. Okay, by simply converting the public constructor to private, what will happen is we are no longer be able to create instance as we like. So one thing we have covered, we have blocked the creationals, the creational from the outside, the creation of the instance from the outside, we have blocked it by simply converting the public constructor to a private one. So that was easy. Then what will happen is anyone who is trying to use this class can't just call and create a new instance. That is forbidden right now. Okay, so the first thing is So the first thing that we have to ensure that class has just ensure that have one single instance. So to ensure that, what we need to do is we need to make sure nobody outside of the class is able to create instances. So we are not giving them right to create any instances. We blocked it. So the option of creating is stopped. The second thing is provide a global access point to that instance. That means we need to make sure, okay, if we are not allowed to create, then how are we going to access that? How are we going to access? How are we going to create something? How are we going to create it for the first time? The one and only we should be able to create, right? So within this, even without using two instances, I can't even create one instance, because even in the singleton, we should have one instance, right? Now we are not able to even create that one instance in here. So how we gonna make sure that this is possible? That how we gonna make sure we can create one instance and we can access that? So the solution is, first thing is the solution is we need to create a static method act as a constructor. Okay, so we will have something called a static method which will act as a constructor. So if you want to create, or if you want to access the instance, what you will do is that you will not use the default constructor, but we will give you a static method which you can refer the instance if you want. Okay, that is the second step. So you guys can see the real world, how we're gonna represent this in our application. So we have a singleton. In our case, this is called user, and we will have something like, if you guys know that there is within the class diagram, a minus sign in here represent a private method. The plus sign in here represent a public method. Okay, so we have we have an instance name instance. Okay, we have a field name instance, and it's going to be the same type of the class. Okay, the field type, the name of the field is going to be instance, and the type of it's going to be the same as the class itself. And you guys can see the constructor. This is the default constructor. How we do know that it is the default constructor? It's had the same name as the user, and it is not taking any parameters. So we consider this as the default constructor. Now you guys can see default constructor is with a minus sign, indicating that it is a private constructor. Okay, and the get instance method, this is a public method. You guys can see it is public, and get instance will return a class type. In this scenario, the singleton, the class name itself is singleton. So the get instance method will return a singleton. So we'll implement this in our class as well. So we have a private variable called instance, the same type of the class. So how are we going to do that? So we have something called private instance, and the type will be user. Okay, it's going to be the same type as the class itself. I hope the spelling is okay. Instance. So we have a private instance. So this is going to be our singleton itself. And we have a private constructor. Here, there you go. We have the constructor in our application as like this. And we have a static get instance method, which will return a singleton, which will, in our case, it's going to be a user. So the implementation for that will be get instance, okay, and the return type would be a user. And right now you guys can see it is saying, okay, if you are if you the function who's declared neither undefined nor void must return a value. Okay, so we need to return something. So you guys can see there is a private instance which is also going to be a type of user. So I can say I will return this instance. So then again you guys can see, rather than having the default constructor, now what we have is what we call we have something called this document. So rather than creating this instance from our application, from our constructor, we have something similar to that. That's going to be a get instance method, and it will return a single instance of this user. How are we going to make sure that this is the instance that we're going to do? We have a privately, we have created a private instance. We actually name that one as instance as well, and it's going to be called, it's the type, it's going to be user. So if somebody need an instance of the user, remember we will have only one instance, so we will return the privately created instance in here. Okay, but the problem will arise, what if so you guys know, if somebody is interested in the user singleton, if you call this, it will return the instance, and you guys can see the instance is right now, it is not initialized. Okay, this is null at the point. We have not created an instance, because in order to create, we need to call the constructor. In this scenario, the constructor is private, so within the class, okay, the user class has a method called get instance. Within this class, we can call that constructor and get it done. So how are we going to do that? We're going to call if this dot instance equal null, that means we have not initialized this. What we call is, we will say this dot instance will be user. So since this is a private variable, private constructor, type of, okay, new, we need to create a new event, new user. So if it is null at the first time, then we create a new user, because since this is a private constructor, only the class can access it. All right, this is what it has done in here. And you guys can see the pseudocode, or the instruction set that you will be needing to create such and such. And we can see the use case of this design pattern. Okay, this is like the pseudocode. Anywhere, any programming language, you can use this. Okay, make sure you follow this instruction. As I mentioned earlier, this is not an algorithm. This is the way that you should do. This is going to be the way that it will be working on. And this is going to be a static field, private static field. That is something that we need to do. If I do static, what will happen is I can't call this. Okay, why I can't call this in this scenario? Because this is, if I call this, it's mean the instance that we are currently in. That means the object that we are in. So we can't use that. So let me go back to TypeScript implementation. Probably we'll have something like this: private static instance of singleton. Get instance, it's going to be a static. If it is not created, we have to create that. So we'll create user dot instance if it is null. Okay, we will say user dot instance equal new user. That is what we have done in here, and return user dot instance. Okay, since this is a static variable, we can't use the word this. This implies to the object that we have created. So by defining a static, that means this will be a class variable. Okay, it will be belonging to the class, not to the object. So if we use this, it's going to be an object, but since we are using a class variable, we need to make it static. That's why this instance dot static got called, and we are returning that. And how do we access this? We need to get hold of this get instance method, but without creating this instance method, without creating an instance, since this is a class method, we can't access that. So what we need to do is we need to make sure that one is also static. So this method is also becoming a class method. Okay, so we have a class method in here. So if I want to access the singleton, what I need to do is, it's basically say the instance is not accessible. Then what we'll do is we will say user dot get instance. Okay, by calling this method, what will happen is it will call this static method, what we have right in here. And first of all, if it is not initialized at the first time, then it will try to initialize. If it is null, it will create a new instance and assign it, and it will return the instantiated one. So since this is a private one, we can't access this something like this. No, it is not possible, because it is not, why do we restrict this? Because it is not initialized at this point. It is not initialized at this given moment. So only way that we can access to this get instance method is just call the get instance method. Then again, say for instance, I want a referent to the user to user dot get instance. This is the only way that we can access. Since the private constructor, we can't create new object, and the get instance method will call. If the instance is already there, it will return it. If it is not, it will create the instance and then it will return. So the first call, when we are calling at line 16, the get instance method, probably the instance is not assigned, not initialized. So the value would be null in here. Since it is null, a new instance of user is created and assigned to user.instance static variable, this one. Okay, then it will return the created variable. We have that in here. Then the second time on line 17, when we want the same instance to be worked with, we call the user.get instance. But now, since line 16 call has initiated the user instance, the if condition is false, it will return directly the user instance that we have created in here. Okay, so the first one will initialize and return. The second one will, since the first one has already initialized, the initialized version will have. So the instance that we are always using, user2, user1, are the same instance always. It's going to be always the same instance. So this is how we can achieve singleton within TypeScript. Okay. So remember, as I mentioned earlier, this is the blueprint. That's why we have this pseudocode. Okay, we have the pseudocode for our singleton implementation. So any other application, if they want to implement such and such, they can follow this instruction set. They can have the what do you call the they can have these instruction set, and they can have it implemented within the language of choice. Okay, so this is the blueprint. This is like how we're going to do it. The way you can do it is going to be different on the language and everything. So we have seen how we can do it in TypeScript. Okay, we have seen it in TypeScript. Let's say, for example, I want to make this happen in Python. Okay, so luckily this site gives us singleton pattern in Python. Okay, so if you need the same implementation, the singleton implementation within Python, there you go. This is how we do it. Okay, so you guys can see we have an instance, and in Python we do not have access modifiers to annotate things like whether it is private or public. What we have is this underscore. Okay, underscore is an indication saying this is a private method or private instance, and we will have an instance of that, and it's going to be an empty at the beginning because we can't have null initializations on Python. And when we know when we need the singleton, there is this class annotation, then there is this class metadata and singleton method. That's how we're going to override the singleton. Okay, and you guys can see it's when we call the business logic and we call the singleton, it is gonna return the singleton each and every time. Okay, so the class.instance is not available. We need to have this call method implemented, and once we are done with the instance, we will always return the implemented instance. Okay, so you guys can see that language to language this is different. Okay, the implementation is different, but the concept of singleton will remain same for the two programming language. Okay, so we can go to another programming language such as, let's say, Swift. Okay, let's go how we have seen it in Swift. So we have the class called singleton, static variable, and it's can be shared a singleton, and it will create a singleton and it will return. Okay, there is the init method and some business logic if you want for the singleton. Right now we do not have. So we have an extension in using nscopy, and we will copy, and you guys can see we will be using the same singleton throughout the application. Okay, so the concept, if you don't know Swift, that is okay. Okay, I don't expect you guys to learn Swift at this point and get everything to know, but at least a language of your choice, at least what you are currently with, you guys should have an understanding. The pattern that we are talking in here is universal to every languages, every implemented languages out there. So for example, let's see Java. I think it will be quite similar to TypeScript, if I'm not mistaken. Yes, you have some more keywords like final, singleton. It will have a single instance, and it will try and it will create this value, the singleton, and you guys can see the constructor is private. And there is a static instance called get instance, and you can pass a value. In this case, we have not done anything. So if the instance is null, we create the value and we will return that instance. Okay, so the implementation sometimes, depending on the programming language, it might look similar, but in reality it can be totally different, because you guys need to know how to make constructor private in Java. Okay, you guys need to know how to do that in Python. Okay, the implementation will be different, but you need to follow the instructions given by that, and there will be a get instance method. Likewise, you have to work with the programming constraints. Okay, So in programming languages like Python, we don't have getters and setters. So we might just call the class and get it done. Likewise, however you're gonna do it, you guys need to implement implement it in the way the programming languages has intended. Okay. All right. So so we know how to create a singleton. We know how to create a singleton, at least in TypeScript. We know what are the main things to we know the things mainly things that we should follow when we are creating a singleton. First thing is a private constructor and a static variable to access that. That is two basic things that we need to know. And applicability. So where do we going to use singletons? Okay, so we need to know. Okay, we have created the singleton. Okay, that is okay. And what are the use cases of singleton? The first thing that you guys have seen, the database connection. Yes, database connection is singleton because it is resource consuming. What are the other what are the other use cases of the singleton? Okay, that is where your knowledge is coming to kick in places like using these in real world. Okay, so you know the concept of singleton, but you have to have the knowledge of applying this singleton pattern wherever it is necessary. Okay, so these are like tips that you can use. Okay, use the singleton pattern when a class in your programming should have just one single instance available to all clients. For example, a single database object shared by part of your programs. Okay, that is what we have seen so far. And so we disable all the other means of creating an object. We can't create an object because the constructor is private, right? When we mark the constructor as private, we can't create any objects. So there is sometimes will be helpful on some other occasions as well. For example, you might do not need to create a singleton, but a special derivative of singleton. Okay, you might need to create what we think is like two different instances. It's not singleton, by the way. It's not going to be singleton. Maybe something that you will use in a special case. Okay, I can't explicitly say this is going to be special case, but say for example, we want to create only two instances of the same application. Okay, so in a scenario like that, now you know how we can prevent others from creating other code or other code generators stopping creating an instance. So all you have to do is make your constructor private. So by learning those things, even though singleton is not, maybe it is not your use case, but you know a method how you can block creating multiple instances. Even that is sometimes a learning point for you. Okay, by knowing the pattern, by knowing these tricks and tips, you will be able to achieve something even more customized for your need. Who knows? So the next thing is use singleton pattern when you need strict control over global variables. Okay, so when you have a global variable, that means you don't want everybody to create variables within your application. So use singleton pattern in a case like that. So sometimes this can be used what we call a cache in some scenarios. Maybe you will have a cache, a global cache of your choice using a singleton pattern. Okay, so that's kind of use cases are there. Okay, so make sure if you need something like a global variable, use a singleton. Okay, so you can say, okay, we have a global variable such and such, but other people might find exploits. Other people say, okay, even though this is global, we can create our local variable on it. So prevention can be achieved by simply applying the techniques that you have used in the singleton pattern creation. Okay, all right. So we have limited our interactivity with the application creation by only giving get instance method. Only the get instance method will allow to access the global variable. So that is also helpful when we want to create a global application in this way. Okay, global variables. Okay, singleton is as I mentioned earlier, is one pattern. Okay, it is one pattern that that we can use. It has its pros. It has its cons. So you should know pros and cons. Okay, learn your pros and cons. Otherwise, what will have is um, messed up code which will not work either way. Okay, so know where this is good, what are the good things, what are the bad things, so you know whether it's going to be useful in the future or not. Let's look at the pros. You can assure that class has only one single instance. That is the name singleton, only one will be there. You can get global access point to your instance. That means you can have one instance that is governing most of your application variables. This is something really useful when you have when you want to create global variable that will be used within the whole application. So this kind of implementation, as I mentioned earlier, the database connectivity, and sometimes there are certain places like state management. Okay, we haven't got into that in our curriculum, but there's something what we call a state management. A global state of your application can be achieved using a singleton state. Okay, so in a brief, in a nutshell, what a state is: the current situation or the current shape of the application, um, and we can mutate that current state and achieve different states. So to create such a thing, to create such a state, we will be using a singleton. Okay, a single object will initialize only when it is requested for the first time. Okay, this is something really interesting. So the instantiation of this class is gonna be happening only on request. Okay, so if you guys can remember, we could have done the we could have set the instance creation while we do in the constructor. We have the public constructor, sorry, private constructor. We could have done the initialization in the constructor itself. Okay, but what we are going to do is we're going to be instantiating this user class only when the get instance method is called. Okay, we are not creating instance of user on the constructor, but we are only making a use of that within the get instance method. There are two things, of course. You can't have like the constructor put in here because it's going to be a loop, first of all, constructor. And the next thing is user resource allocation, the resource allocation will only happen if you call this get instance method. You need to call the get instance method that will lazily initialize this and get back. Okay, all right. The next thing there is the bad part about it. What's wrong about, and what are the places that we should avoid using Singleton? Violate single responsibility principle. The pattern solves two problems at one time. Okay. The first thing is single responsibility principle. So this is one of the principle that you will quite oftenly see within programming world. The single responsibility principle is in a nutshell, we can say a class should have only one thing to deal with. Okay, so the instance class that we have creating, the options, the singleton that we are creating should do only only one job. Okay, there are several reasons to have the single responsibility principle to avoid complication. Okay, let me give you an example. So we have a class that it will work on a class that can let's say it can sing song. Okay, there is a class which says sing a song, and there will be a same method or responsibility for let's say play a piano. Okay, so there are two things the class can do. One is sing a song, the other one is play a piano. Okay, so by introducing two activities, two responsibilities for the same class, what will happen is the class is getting complicated. The complication comes in all the things related to singing a song, and all the things related to playing a piano would be within one single class. So what will happen? So somebody who's only looking at singing a song might end up using some variables or some methods intent for playing the piano. Those can be mix and match. Okay, so by introducing lot of responsibilities for a same class, what will happen? The class is becoming more and more complicated, and when the class is more and more complicated, what will happen? The testability is not there. We can't test that everything because it's there are too many things to test, so it will be hard to test. And manageability, when we want to create it, it will be really hard to manage. Okay, so we don't know which is the which one is used for the class to work best. That's going to be a problem. So to avoid such scenarios, to avoid such use cases, what we can simply do is make our classes a single responsible. If the class is doing only playing piano, let it have all the things related to playing a piano only. Do not mix the class with singing a song. We can have a separate class for do that. Okay, that is okay. As long as it is doing what it's supposed to do, the single responsibility is kept on tact. Okay, so how that affect in singleton pattern? Sorry. So singleton pattern, when you are using singleton pattern, you guys can see that it solves two problems. Okay, Let me show you what are the problems. Da, da, da. Singleton pattern. Da, da, da. Okay. The singleton pattern, what it does is it is violating the single responsibility. It is having multiple responsibilities. Okay. And the pattern is trying to solve the problem, solve two problems at the same time. So when we use singleton pattern, it is solving two things. The first one is yeah, was it the problem? Yeah, in here you can see the problem is ensure that one class is instance is there, provide a global access point. So it is doing multiple things. Okay, these are the two problems that we are solving. And when we solve those two problems, it is violating the single responsibility pattern, single responsibility principle. So when such a thing happens, the class is becoming, sometimes it's become hard to manage, as we explained earlier on. So make sure this is a con side of the application. We are not able to do that. The next con is the singleton pattern can mark a bad design. For instance, when components of the program know too much about each other. Okay, that means so sometimes we want to hide some implementation of the application. Okay, we do not want the application to know a lot about this class, especially with the user class. We don't want the user class to know everything that it is exposing to the world. But with singleton pattern, what will happen is the exposing, the masking part is really hard to do. Okay, that is also another weak point or another error that we will see in the singleton pattern. Okay, we'll try to see this in action. Right now, just remember, it is not easy to design. It is hard to hide some internal components to outside. So the next thing is the pattern requires special treatment in multi-threaded environment. So the multi-threaded environment won't create single objects several times. So this is one of the errors that you will find in languages such as Java. Okay. Problem is if, for instance, let's take this scenario. Okay, within this scenario, what will happen? The line number 16 will get executed, and after its execution is completed, line number 17 will get executed. This is the execution order of this function. But what will happen if these two lines, line number 16 and line number 17, were executed at the same time? Right now, this is not happening in here. After 16, it will execute 17. Yes. But think for a second, we were able to execute 16 and 17 at the same time. We are executing it at the same exact moment. Okay. That can be achieved if you are using something like multi-threaded application. That means this is if you are running this in a single thread. Okay, this function is running in a single thread. Only this will be happening. Okay, but say for instance we are running this line number 16 in one single thread, and line number 17 in another thread. Okay, there are two rival threads which is executing the same instruction. So what will happen in a scenario like that? What will happen? So the problem here is that since these are like calling the same method at the same time, it will arrive this if condition on the same time. Okay, we are calling these line 16 and 17 into threaded application. That means let's say, for instance, one CPU, we have multi-threaded this application, and one CPU is executing this. At the same time, another CPU is executing this line of code, okay, in a multi-threaded application. So what will happen? Both will arrive this if condition at the same time. Okay, so the line 16 1C, okay, the user.instance is null. It will try to create an instance. The second threaded, the next threaded application will come to the same time. It will be the same time that they are coming. So the when the other thread is coming, it is seeing also it is null. Then we are creating another instance. Now you guys can see in a multi-threaded application, the instance creation, this can be a little bit tricky. Okay, two instances are accessing the instance is null, so it is creating one instance. So it's going to be a tricky part to handle in multi-threaded. Of course, something like this in a single threaded or in an algorithm way, you won't find any problems by creating. But in a multi-threaded application, this would not be suffice. It will create two instances. So in order to do that, in order to avoid such thing, in order to avoid such instance creation, we need to make sure that when we are executing this, this instance creation part, at least this static implementation, statically creating this part, we need to make sure this is thread proof. That means if two threads are, if this method is called from two threads, then we need to make sure one of them is not accessible or one of them is blocked until the other thread is completed. Okay, so even 16 and 17 are executed simultaneously. In a multi-threaded application, we need to make sure that we are not allowing both threads to execute the same instance or get the instance method at the same time. If line 17 is the first, or if line 17 and 16 are in a race kind of situation, one should be completed. It might be 16, it might be 17. One of them will complete. Once it is done, the second one will be able to call. By that time, the second one, when the second one is called, already the instance is created, so it is not making duplicates. So in a multi-threaded environment, if two threads are trying to complete this, we need to have thread safety. We need to have thread safety. Right now, within this TypeScript example, you won't see any type safety. But programming languages like such as Java, we would use something called a synchronized block. Okay, we have something called synchronize. Yeah, this kind of block, which will block multi-threaded access. Okay, we will make sure in a multi-threaded application this won't happen. Right now, this is TypeScript. It is not going to happen. But in a scenario like Java, we need to make sure we have to have this special keywords, special functionality, special things that will prevent such a thing.
So it won't create accidental instances. Okay, so there is a special treatment when we want to create multiple multi-threaded environments. So that is a bad point. Okay, and the next thing is it may be difficult to unit test the client code of the singleton because many test environments rely on inheriting the producing mock objects. Since the constructor of the singleton class is private and overriding static method is impossible in most languages, you will need to think creative way to mock the singleton, or just don't write test or don't use singleton pattern. So this is one of the major issues that I see in singleton. That is, it is not most of the programming languages, the testability is really hard. Okay, it's coming because we are using some mechanisms, or we use some sort of techniques to test classes. When we are, say for instance, I want to test the user class. Okay, so most of the programming language use what we call a technique called mocking. Okay, it is it is something that we use frequently, most of the time, to test the class itself. Okay, but when the application is constructed in singleton, most of the programming languages do not have the capability to mock private constructors. Okay, the mocking rely on the public constructor. Okay, the mocking most of the time happen based on the public constructor. But since we have disabled the public constructor, now there is no way that we can mock the instance. Without mocking, it is making us too hard to test the application itself, test the class at least itself. So that is a problem when it is coming to testing. Okay, so even though you guys do not might not have heard about testing or mocking or something like that, that's okay. But remember, most of the languages, frameworks, they rely on the public constructor to do the mocking, or to have a duplicate, or to have a clone or something like that. Say something like that. It's completely blocked, so we can't use any mocking framework or some sort of like that. It will be hard for the environment to mock. So then what we have to think is either we need to skip test on that class, or we need to make use of a different pattern, different creational pattern, not the singleton. Singleton wouldn't be a good choice when it is coming to testing. Okay. So there are like relationship between these patterns. So these facade fashion and lightweight have some relationship in between singleton. I mean, there are like derivatives, or there are like similarities. There are like things which is something similar to singleton, but we will be not looking into the relationship. The uh, the main thing that you guys should have from the singleton pattern, why it is used, and what is the solution, how we gonna make this singleton, and what are the pseudocode or maybe implementation from something like TypeScript, and what are the pros and what are the cons of the singleton pattern. Okay, so that would do in order to in order to make sure this these things will be understand for you guys. So make sure follow these things. What is the problem? What is the solution? And how we're going to do it in 2 different steps. Remember the private constructor and the static method to access. That's it. Okay. So have a look around this. So you guys will get know the singleton pattern. So there are like a lot more other patterns that we need to that we can discuss. So we'll see about other design patterns on upcoming lectures. Okay. All right. Anything that you guys need to ask before we wind up? Okay.